All right, so we have x to the 5th. This is associated with question number 4 on your notes. So we have x to the 5th minus 2x cubed minus 1. You see I got that entered into Desmos. And here's what it looks like on the graph. Now in this case, we have a point of intersection here. Let's see, that's at negative 1.179. And then another point of intersection at 1 point, you can see here, 513. Now, notice there's a difference. At the negative, at this point right here, let's see, we actually have 2 points of intersection here. Looked like just one, but if we zoom in closer, we have 1 point of intersection at negative 1.18 and another one at negative 1. And then we come back over here and we have one at negative, or at positive 1.5, right around 1.5. And if I tap it twice, it tells me exactly where 1.5129. So while at first, when we were zoomed in, it looked like there were just 2 points of intersection. Now we can see we have 3 points of intersection. And so we'll go ahead and identify those on the graph. So since we know that there are 5 roots, we have 3 points of intersection, which indicates that we have 3 real roots. But we know there are 5 total, leaving us with 5 minus 3, or 2 imaginary roots. And then part C, which we just identified on the graph a moment ago, we said that those actual roots are located at negative, and I'm going to round to 2 decimal points, negative 1.18, and then our next one happened at negative 1, and then lastly we had our final root was at 1.51. So in summary, the steps you want to follow: first you want, ooh, we didn't even sketch this. Let's see. Let's talk about end behavior real quick. Since we have a positive, looking at our lead coefficient, it is positive and odd. We know that it's going to start down and end up. So we know that the graph is going to start down and then end on the up. We know in the middle we have those 3 real roots around negative 1.18, right around there. And then again at negative 1, right around there. And then at 1.5, let's see, here's 1.5 here, right? Real close to 1.5 exactly. And it's going to come up and then come back down. We know our y-intercept, well, we could figure out a y-intercept pretty easily if we plugged in zeros for x, since f of x is the same as y. So plugging in a 0 here, that's a 0, minus 0, minus 1. So that's going to give us a y-intercept at 0, negative 1. And you can also observe that on Desmos. Desmos is your friend. It is a huge, helpful tool. So at negative 1, we're going to hit the y-axis, and then we're going to come back up. It actually does some interesting things down below, but we're going to focus on just the basics. So this is a sketch. That's important to keep in mind. This is not exact. This is just a sketch of the graph, keeping in mind the key aspects of our end behavior here. This is end behavior. And the y-intercept. And then now we've made this more specific by including our real roots. These are our real roots. Now, we also, it's super important to include the nature of the roots. So by identifying the fact that we know there are 5 roots based on the degree, it's also important to identify, okay, since we know it hits the x-axis 3 times, there are also 2 imaginary roots. And that is our lesson on 9.3, sketching the graphs of polynomials.